Cultures of Programming with Tomas Petricek.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring architects as well as .NET engineers who'd like a path to become an architect. You can go to clearmeasure.com/careers for that. Our guest today on the show is Tomas Petricek. Tomas is a lecturer at the University of Kent and also a partner at fsharpWorks. He believes that the most fundamental work is not the one solving hard problems, but the one that offers new ways of thinking. He follows this belief in his academic research on programming systems and history and philosophy of computing, but also in his writing on functional programming and in his F# training and consulting. But before joining Kent, Tomas did a Ph.D. on context-aware computations at the University of Cambridge. He worked on F# tools in Microsoft Research and built novel tools for data exploration at the Alan Turing Institute. Tomas, welcome to the show. How are you, sir?
Thank you for having me. I'm good. How are you?
Good, very good, very good. My pleasure. You've done some very interesting work along the way. We couldn't possibly capture it all, but I'm always curious. Someone who's done a lot of research in formal research institutions as well as professorship work at universities. What does that career look like that causes you to move into this field? What are the high points that have led you here?
Yeah, I mean, I think for me, it was always the sort of interest in doing my own thing. So that's one of the things that within some constraints of the academic environment, you get to do. So if you get interested in functional programming, you can do research on that. If then you sort of lose your interest in that and get interested in data science, you can do that. And if you want to do something crazy, like look at the history of programming or have a sort of more philosophical perspective, you can still do that. So I think that's really the high point for me.
Okay. And there are some listeners out there, because we have just the growth of the industry is huge. I know you probably have a unique perspective. Can you give the listeners an overview? What is the Alan Turing Institute?
Well, this is a data science research institute and AI research institute in the UK, which is actually a pretty interesting organization because it sort of tries to combine the academic research that people do at universities with somewhat more applied work and sort of bring those theoretical ideas to practice. So they've also got a large number of research software engineers who are actually sort of working on turning some of those less well-programmed academic projects into something that someone could get as an open source project and actually use.
Yeah, the name Turing, there's the Turing test, and I think everybody who goes to a formal computer science program learns a little bit about Alan Turing the man. Is his influence still going strong at the institute?
I mean, I think his influence is mainly sort of he's a very well-known UK computer scientist, so I think that's why they sort of picked his name. Of course, there's sort of a lot of I mean, I don't think there's particular sort of data science angle on his work, but he does end up being pretty influential in both sort of academic approaches to thinking about programming, the work on Turing machines and computability. But he's also designed one of the earliest UK actual computers in the 40s or 50s. So that's maybe why computer scientists like to treat him as their hero, because it's got this sort of both theoretical and applied angle.
You teach, on a regular basis, and you've been doing some presenting at conferences. I want to ask about one in particular that you've been doing around cultures of programming. That's fascinating. You've got it subtitled "Lessons from 70 Years of Learning How to Control the Electronic Computer." How do you distill 70 years into something that's even understandable in a reasonable period of time?
Well, yeah, I don't think you can really distill it, but I mean, what that work was sort of, I mean, in a way, that work, even though it sort of ended up being about history, really started with much more sort of contemporary motivations, because I was always, with a lot of the work I was doing around F#, going to various industry conferences and really enjoying the conversations there. And especially if you go to a place where kind of different programming language people meet, and you get like someone who's really into Erlang talking to someone who's really into Haskell. You encounter all these interesting conversations where they kind of talk about the same thing, but can't really understand each other. Like the Erlang people will tell you, well, of course, you need to be able to restart your processes if you want anything to work reliably. And the Haskell people will tell you, oh, you need types, otherwise your thing will never work. And you need to sort of prove your program's correct. So you get these like very different perspectives on what programming is. And I sort of started with this motivation of just going to a nice developer conference a couple of years ago. And then you sort of read some of the past conversations that people had around software engineering at the end of 60s, or kind of how to control personal computers in the 70s. And you get a lot of the same discussions, the kind of similar arguments. So yeah, that's how this idea turned into a massive project for me that it currently is, because it's really sort of interesting whether there's like similar patterns almost, or similar ways of thinking that you could follow throughout the history.
Yeah. Well, it's interesting, your approach to this as cultures of programming as opposed to eras of technology.
Yeah.
So what's the thinking? Can we get into your brain around that angle?
Yeah, I mean, I think an error is something that everyone would sort of agree on. Like something goes wrong, and everyone kind of agrees what was it. I think what's interesting here is that it's not that the people sort of disagree. They kind of talk past each other. And I think that often comes from just having very different sort of basic idea about what programming is.
What were the early cultures of programming?
So, I mean, very early on, you had the sort of first programmers was really a mix of people coming from other disciplines. So you had a bunch of mathematicians, engineers, and so on, but also sort of human computers who were typically women, hired to do manual computations back before you could do it on a computer. You had people from various sort of psychology worlds and so on. So there really was sort of very early on a sort of strong engineering angle, but as soon as it becomes sort of possible to think about programs as sort of separate entities that exist outside of the computer, you get this mathematical thinking of program as a mathematical entity that you could formally analyze. And then when people started sort of directly interacting with computers, you get this perspective that program is really, you're not really thinking too much about programs as things you create. You just interact with the machine, and at some point you get it to do what you want, but you don't really think of like writing a program.
Just giving it instructions.
Just sort of interacting with it and making it do the right thing. But you sort of flip switches in the early days or type things in an interactive command line. And eventually you shape the state of the world to do what you want.
Yeah. Well, so when did that change?
This is sort of, I think this is a constant struggle. So in the sort of 50s, you had this batch processing mode where you fed your computer a stack of punch cards, and then, or you don't even feed the computer, you give it to an operator who will sort of get back to your office next day and tell you syntax error on line 34.
Don't.
And then you go again. So this was very, very inefficient and very tedious. In the 60s, in MIT, people had first machines that you were actually allowed to sort of use interactively. That's where the hacker culture started, because that's sort of all your typical programmer stereotypes of bearded people with sandals on, waiting at 4 a.m. in front of the machine, because that's when it was available. To sort of fiddle with it directly, flip switches, write bytes directly to the memory. And I think in sort of more recent times, if you look at something like microcomputers in the sort of 70s, 80s, that was something where you, again, could interact more directly. But I think the direct interaction, in a way, is something that's kind of commercially much harder to encapsulate. If you want to build something, then you kind of need to have a finished thing that you can deploy. So you always have these like periods when people interact with computers more directly, and then that gradually gets replaced with something where you end up with a sort of finished thing that's a program that you then deploy.
So you mentioned the punch cards, and at some point, code became something that we started reading, and now people argue about it. What are we jumping too far ahead, or were there any intermediate stages in the changes?
I think this is kind of, I really like this realization that the idea of programming languages is something that's actually hasn't really been very obvious, because that's still pretty ancient. So it sort of goes back to the end of 50s when sort of Fortran, Lisp appeared, and then ALGOL came. And the really interesting thing here is that like Fortran was specifically designed for one particular IBM machine, and it stands for Formula Translator. And if you read the manual, they don't really consistently call it a programming language. It's just sort of a way of interfacing with this particular machine. And then ALGOL was designed by sort of more academic crowd as a universal programming language, and that's where really it sort of got this name as well, as a thing that's independent from a specific machine. So you get this like move from basically I have buttons on my toaster, which are the instructions, to now I've got a mathematical object that exists on its own.
So was ALGOL the first intentionally designed programming language?
I mean, even Fortran was designed, but not as a programming language, more as a sort of clever set of instructions that can be automatically translated and executed by the machine.
And then Fortran ended up outliving ALGOL because it got adapted with all these different versions. Right?
Yeah. I mean, the sort of tongue-in-cheek explanation is that ALGOL was designed by all these European mathematicians who didn't have actual computers, so they had to do all this sort of thing as a hypothetical exercise. It was actually a mix of US and Europe academics, but not the IBM people who actually had computers.
Right. I remember my father, who's retired as a master electrician, he had to learn some Fortran in order to program some of the electronic modules that he just happened across in his field.
So that sounds cool. Yeah. I mean, yeah, Fortran definitely is still around. And I've got a colleague who's doing some work with climate scientists on basically fixing their Fortran code.
We'll be back to the interview in just a bit, but first, I want to pause to celebrate our 200th episode. I started the Azure DevOps podcast back in September of 2018, and I was really blown away that it quickly became one of the most popular podcasts for people searching any of the directories for either Azure or searching for DevOps. And we've had tremendous guests on the show, and we love talking about any topic that's interesting to people who are shipping software using Azure, .NET, and everything that surrounds it. And of course, a special thanks to Carl Franklin, who kind of gave me the rundown for how to set up audio and recording and all that. So thank you, Carl. A few listeners and past guests have left some messages about show 200, so we'll roll them here. And then we'll roll the normal commercial, which is really important since ClearMeasure has been such a great sponsor of the podcast since inception. So if you haven't checked out ClearMeasure, please do so. They help .NET software teams become more capable so their employers can do more in-house and outsource less. And then finally, thanks to all you listeners who've subscribed and listen regularly. If you would like to hear a particular person on the podcast, go ahead and tell me by writing into podcast@palermo.network. And finally, thank you all, and God bless you.
Hi Jeffrey, this is Mark Seaman. Congratulations on show number 200, or as we would say in Danish, tillykke med episode nummer 200.
Jeffrey, congratulations on show number 200. I'm glad to be a part of it.
Hey Jeff, this is Sam Nasser. Wanted to congratulate you on your 200th episode. Great job. As a listener and subscriber, I've always appreciated how you covered a wide range of topics and with some leading experts, and you always get to the essence and the fundamentals of the topic. As a guest on your show, a two-time guest for that matter, you were always very welcoming and accommodating to any schedule changes of the recording, and it was very helpful. As a colleague in the industry, you're always willing to help, which is something that's huge and highly appreciated. Congratulations once again on your 200th episode, and looking forward to your next big milestone.
Hey, this is Henry Quillen. Just want to say congrats for 200 episodes, and thank you, Jeffrey Palermo, for bringing me on the show and all the awesome wisdom you've shared with me and the community.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
Fast forwarding to today, we argue as an industry, we argue all the time over languages now. And which language should we use and but it still ends up being somewhat tied to the machine, doesn't it? If we want to program the iPhone, guess what? We gotta, Apple wants us to use the language that they designed for their machine.
Yeah, I mean, that's right. And in a way, many of the languages are kind of similar, at least on the sort of formal mathematical side. So a lot of languages are getting some functional features, and I think what's maybe a sort of bigger difference is this. It's definitely this change between sort of I write a program in a language and then I have code, and there's this perspective of I interact with a machine and it will do something, and it will sort of react to my edits. And that's something that has been the case with Smalltalk. That's the sort of most obvious example of it, where you had this Smalltalk environment with objects living in it, and you started it, you sort of browsed through the objects, modified some of them, then you kind of turned it off. It remembered all the state. You turned it on again and continued. And that's a very different style of programming, which I think is kind of it's kind of a lot more interesting. And I can sort of imagine you could do interesting things in such an environment, but it's something that I think has pretty much disappeared with sort of end of popularity of Smalltalk and Lisp machines.
Yeah. You had mentioned the hacker culture. There are so many more people using computers today. You mentioned the hacker culture. They just sat around the computer. They figured out how to get it to do something. Heck, people who are making YouTube channels and all, they're figuring out how to get the computer to do something, but we wouldn't think of them as programming. But how do you think of those people? Lots of people using computers in pretty deep ways.
Yeah, I mean, I think that what I call the hacker culture is this sort of reappearing trend of people getting their hands sort of dirty with computers pretty directly and doing whatever they sort of can do, from the sort of MIT 60s where you did this at 4 a.m. to the microcomputers where you could buy one and just figure out what it does. I don't know, where I think what's interesting about this is that it always kind of appears in places where the established programmers don't think of it as serious programming. So the serious programming in the 60s was the punch cards. The serious programming in the 70s was some sort of workstations and larger sort of time-sharing systems.
Mm-hmm.
So what it's sort of hard to say what are the places today that I don't think of as real programming. It's probably, I think you can do a lot with sort of hardware, maker spaces, tinkering kind of stuff where you just have to, I don't know how you even program these things. Probably some sort of mix of low-level C and
Microsoft
whatever.
Excel. There's tons of people using Microsoft Excel, and some of those formulas kind of, you look at it, it's like, man, that's some pretty involved code right there. They have embedded if statements and loops, and
I think that's another really good example of something that is really important programming, but nobody would think of it as such. Or data science, which I've done some work around, is, I think, another example where you really do a fair amount of coding if you're analyzing data, but it's not traditional programming in the sense you don't often want to end up with program. Your final result is a sort of answer to a data science question or a chart that explains something. So that's another sort of weird type of programming that I think is interesting, and you can sort of see that in the languages as well, like Python. Well, that one is a sort of language designed as a programming language, but the other thing that people use is R, which has really been built. The joke about R is that it's a programming language built for statisticians by statisticians. The first part of that is good, but the second part not so much.
Well, yeah, I don't know more than a handful of people who would say that they've gotten really good at R. It's more of a more specialized language.
I don't think you can get good at R.
Oh, okay.
No, I mean, the funny thing about R, I mean, R works extremely well for what it does. It has all these strange ideas that really make sense, that they really sort of solve some particular problem that only a data scientist might have. Like when you're calling a chart function, you give it your x and y values as arguments. And the chart function can actually figure out what was the name of your variables that you passed it as an argument, which is really helpful because it can use it as labels for the axes. But it's not something that most languages can sort of do in any sensible way.
Right. Yeah. C# doesn't have that capability, I don't think.
I think you can do it with F# with this sort of mechanism where you mark your argument with some particular attribute, and it will capture the source code that was there. And if that's a variable, you get the name of the variable. And in F# this was added pretty much specifically by sort of for this kind of use case. I don't know. I wouldn't be surprised if C# had something like this or got something like this in a couple of versions.
Yeah. We can get the name of the current method's arguments, but we can't get the name of the variable of the calling code.
Yeah. I mean, I guess you could get the link expression tree, but I don't know if that would work with variables. They might just end up being embedded as values.
Yeah. So what's your prediction on where the culture of programming is going next? You know, there's obviously Microsoft is pushing low code with their Power Platform and Power Apps and all that. And then of course Salesforce has some similar things. Zoho has a lot of those low code capabilities, and more vendors are providing that. But you think that's really going to take off and be the next wave, or what's your sense?
There's this amazing ad for a programming system called Flow-Matic, which has this like really nice sort of blue color scheme with some icons of happy people on one hand, and a sort of more inspirational quotes on the other, where it says, with Flow-Matic, finally you will not need any programmers. I don't know how exactly it's phrased. I'd have to look it up. Sure. But it really says sort of eliminate all your coding load with Flow-Matic. And this is an ad from the, I think 50-something, 55, 54. And this, so the idea that we'll have sort of, this was basically the first sort of attempt at doing high-level programming languages before COBOL, where, of course, the dream of COBOL is your domain experts will write the code because it's just English. I mean, so I guess my answer is it really depends on what kind of programming you're trying to do. A lot of programming is oftentimes you don't really have to specify anything too complicated. And of course, you can sort of package those things into reusable components that you can plug together. I think this works as long as the components kind of cover everything you need and they fit together well. I think often this kind of depends on the builder of these components. I mean, if you're thinking about like a specific domain, then you can probably build all the components that you need to cover that domain. But as a general purpose programming problem, I don't think you can kind of make the complexity go away. It will always be there somewhere. You can package it to some point. So
that's a good point.
I think you kind of always need these escape hatches. That I think is a sort of fundamental flaw with the no code and low code approaches. It works, but when it doesn't, what do you do? Right. Either you're screwed if they didn't give you any option, Or if there's some sort of escape hatch, you will have to go back to C# or whatever and do proper programming. I think what would be really like where some of my sort of ongoing research is kind of trying to go is, what if you could have a sort of more gradual progression? So, of course, like at the very high level, you just plug in some sort of things graphically, and it does what you want. But could you like then have one more deeper view where you maybe see a little bit more, but not everything? Kind of zoom in and do the things that you need in the next level.
Yeah.
And again, like Excel is actually a good example of this, because in Excel, most of the time you're just in the formula mode.
Right.
But if no, you've got the macros, which is like your next level thing that still isn't as horrible as writing low-level C code, but sort of somewhere in between.
Yeah. I like your point of you can do it for a particular domain. That made me think of WordPress and all these other tools where you can make a general business website, and for the use case of having an informational website, yeah, we've kind of identified all the different pieces that you might want in a website, and we can distill them down into components where someone with no knowledge of HTML can put together a website, get a domain name, throw it up online, and they didn't even have to know what the actual HTML or CSS or bits of JavaScript were under the covers.
Of course, then I think one danger of this is that you'll end up with very kind of homogeneous world. Like if you if you look at the archives of GeoCities at the sort of mid-late 90s web, people did crazy things.
Right.
Just because there was no established way of building anything. So you had like all these pages that tried to subvert your system in various ingenious ways, and often that was sort of that user experience, but it also led to this sort of creative burst. And I mean, the web has matured, so you can't really expect that to sort of continue in that way. But again, I think it's worth looking for these like places where programming is happening outside of the established programming world, and see if there's something sort of crazy going on somewhere.
Mm-hmm. Yeah, I think of where the situation is right now with apps for smart TVs and apps for the Roku stick and Amazon Fire TV and the Samsung ecosystem, and how right now it's more specialized. Only businesses are really developing those apps. But at one time, only businesses with dedicated programmers were even having websites, as opposed to maybe just an individual family business. But at some time, is the individual family business going to have a smart TV app? Probably.
Yeah.
If it makes sense from a business standpoint, once there's some company that comes out and says, get your app on Samsung, Fire TV, Roku, just $39 a month. Sign up for this service. It could happen.
Yeah. I mean, that's definitely a sort of different, unusual kind of device, and
they're doing it with smartphone apps right now, where you see there's services that I just recently was researching. Are services that you can pay a very reasonable amount of money, and you can create a full-on app for your community church and have it on Android and iOS, and boom, there you have everything you need in your app.
Yeah. I mean, I think that again sort of relies on you kind of know in advance what the structures of these things will
Right.
need to be. I don't know if you're trying to build a shitty robot, intentionally do some sort of weird thing, then that might be a place where you'll have a lot of sort of creative unexpected things.
Yeah. And then the general purpose programmers end up working for the companies that are building the app builders.
Yeah. But I mean, there's sort of a continuum from like you have a app as such, and you have some configuration to you have sort of programmability in it.
Mm-hmm.
I mean, another sort of completely unexpected area that I find really fascinating is live coded music. This is where you have a sort of programming environment where you type code, run it in REPL to control a synthesizer, and so you can sort of write code to build up a music sort of music thing, and you kind of there's people doing this in clubs, and you just sort of take their machines to club, project their code on a behind them, and have some music performances.
Wow.
So one system that does this is called Sonic Pi, and it sort of started as a thing for teaching kids how to program on Raspberry Pi, but now it's actually used by sort of professional musicians as well.
Oh wow, that's a good one. We'll add that to the show notes.
This is also a place where you experience really different kind of programming. Not your sort of traditional I write program, compile it, and if it type checks, I run it.
Right.
Because you always have it running. And what's sort of much more important is you need to get quick feedback and be able to sort of stop a thing that's wrong or correct it as it goes.
Right.
So it's sort of a running system where you need to be aware of the state and you need to be able to change things in it. And I mean, I think this is something we might even, unlike most of the other things I've been saying, we can actually relate this to the theme of the podcast, because I feel like with DevOps, you might often actually want to have this kind of experience of like monitoring my system live and being able to sort of interject and tweak it and sort of almost like open my debugger live and see what's going on and change its behavior. And then once you know what was wrong, make that change permanent.
Yeah. This is for music. I also ran across one that was for video switchers, like the ATEM Blackmagic ATEM line of video switchers in the professional scene have these macros, which I looked at the language like, okay, you call it a macro. This is a program, and you have to know the syntax, and it creates the frame by frame switching of transitions from camera A to camera 2 or camera B, or putting 2 or 3 cameras together, and the detailed transitions to go from one to the other. And for broadcasters or sports media where you have the on the field camera angle versus the wide angle, and just composing different views on the fly and designing how you want to create them and transition from one to another on the fly. It's all some pretty hairy code behind the scenes.
That's really amazing. Yeah. I mean, I think this is something that must have some sort of origins in a project in Xerox PARC, where there was someone there. I don't remember the details, but all I remember is like Xerox PARC has this reputation for being a place where all the crazy people invented half of modern computing. And it's of course somewhat a myth, but there was like one guy who was even too crazy for even Xerox PARC, who was doing this video composition thing, who they sort of who left Xerox after a relatively brief period and went on to set up Pixar Studios.
Ah, fascinating. Well, as we close up here on our time, if the listeners would like to kind of learn more about the history of programming cultures, of course, that you teach, where can we point them? Where can they dig in deeper?
I think everything that I've actually sort of published is linked somewhere from my website. I recently updated it so that it actually contains links to more recent things I've done. So that I think would be a best place to start looking.
Okay.
There's a draft academic paper around this cultures of programming idea, and I've got a sort of revised version, work in progress. So I don't know how many eager listeners we've got. If I receive sort of a couple of emails saying I'm really interested, can I get the latest version? I'll manage to reply. If this mention will generate 100,000 emails, then it will take me some time. But I'm really happy to hear from people if they found it interesting. Feel free to get in touch.
Okay, and so that's TomasP.net.
That's right. Yeah.
In the .NET community, not to be confused with TomASP.net.
That is a thing I never realized. Even when I set that domain up and I was doing C# and ASP.net, I never realized that's what I've got. So TomASP.net is maybe a better way to remember it.
Well, either way, we'll put all those in the show notes so that folks can find it. So,
but this is going to the good old times of ASP.net web forms.
It's been around, it's been around for 20 and a half years, I guess, in GA.
Wow.
Yep, good run. Well, thanks so much for coming on the show.
And it can drink alcohol.
Oh, that's right. Well, thanks so much for coming on the show, Tomas.
Thank you very much. It was a pleasure.
Oh, my pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.